So one of the tabs we have is this ADC DAC tab. When we click on that, you'll see 4 Java beans show up. Each Java bean is a dial, goes to full scale 100, and it will show the value that is measured from the ADC on the I2C ADC DAC slave. So here's our device. You can see we have a chip and we have an NXP I2C slave chip, which is a 4-channel ADC and 1-channel digital to analog converter, and we've described it before. And we have 2 potentiometers. Each potentiometer goes to an individual ADC, and the ADCs that we're not using, we're taking their signals to ground. So with that in mind, let's take a look at the Pyroraptor Java application. So one of the things we have done is we've set the address of the device we want to work with, which is 4E, which is this pot meter we just showed, and we've told the application to read the ADCs at 300 millisecond intervals. We can set the intervals at, for example, 100 milliseconds up to 10 seconds, whatever. We have a Java thread that runs, that reads the ADC and updates the Java bean meters. So let's get into action. So that's running right now. Let's go ahead. Here's our pot meter, and what I'm going to do is change the dial, and you will see that we go from 0 to full scale, from 0 to full scale. Okay, let's go ahead and zoom into the meters. Go ahead and change the dial. You see that? Very smooth. It's reading every 300 milliseconds. So as you can see, we can simultaneously show 4 ADC channels using these dials. This is very convenient when you're measuring analog signals and you want to look at them simultaneously. This is in effect using 4 voltmeters simultaneously, but doing it through software, through the Pyroraptor USB to I2C bridge, which we have right over here. So here's the Pyroraptor, as you can see. So using the Pyroraptor Java application and the pot meters with the Pyroraptor USB to I2C bridge, you can get up and running in I2C immediately and get a hands-on experience with it, and you can do very interesting things. Like one of the things we do is connect an analog accelerometer to the analog inputs on the pot meter, and as we move the accelerometer, we see the needles move. We have a video, separate video for that. This is a very useful application. Now, the Pyroraptor Java application has many other tabs that we have videos showing various applications using those tabs. For example, one of them is PWM I2C motor control for an arm with 6 degrees of freedom. And we have pan and tilt support, which we have a video showing that. For the pan and tilt, we can individually address the I2C motor for the pan or the tilt, and we can also address the I2C slave-based ultrasonic. And that's what you see here, which is a meter that we use for the ultrasonic that measures the distance. We also have other tabs. For example, Sabertooth. We can control a Sabertooth motor for a rover using I2C slaves that we develop. And here you can see the addresses at 50 hexadecimal and 51 hexadecimal, and you can do things like go forward, tank, reverse, etc. So a lot of capabilities are built in to the Java Pyroraptor application, and of course it is key to monitoring the I2C bus, getting to seeing that individual I2C devices are on the bus and individually addressing them and programming them and reading from them. And you can do this through the control panel.